Here we go. All right. So we're going to do a little bit overview on our senses. We're going to learn about hearing, taste, and smell in the next few days. Balance, motion, all that stuff. We will get into muscles. I did lay out a calendar. Let me go through it with you real quick if I can snag it. Here's what's going to happen, just so you know. Today we're going to do hearing. You have a labeling sheet on the ear, which will kind of help you break down how we hear. So please make sure that you go through that because I'm going to ask for it tomorrow. Okay, so you have one night. I don't think that's too bad because the answers are on the sheet. Okay. I'm going to ask for the labeling sheet tomorrow. So if you want to write due Friday on it, please do. If you're not going to be here tomorrow, then I'll get it Monday. Okay? You already did it? Look at you. All right, so today we're going to go over hearing and taste and balance. Tomorrow we'll talk about vision and locomotion and start on muscles. Muscles is your next big thing that's a little tricky. Okay? So we'll start on it tomorrow. We will not finish it till Monday. It's going to take 2 days. We're going to draw a picture. We're going to do all that, so I'll make sure that you have what you need. When I draw my picture, it will get posted to Twitter. It'll get posted to my blog. You'll have it. Okay? So you'll draw your own, but I will also put mine on there. So Monday is finishing muscles. You've got some math quizzes over the next few days. Your math quizzes are chi-square and solute potential. Remember ICRT? Remember that one? ICRT, the little Triton S, pitchfork S, solute potential. So none of these are new, okay? I think it's a psi when you're talking about, fraternity stuff. Is it called psi or something like that? So none of these math quizzes are new, so please go back and review and make sure you know what you're doing, because I'm not going to review this time. I'm just going to hand it to you. I'll tell you your first one is solute potential, okay? You have 4 before the end of next week. Tuesday is going to be the immune system 1, Wednesday is immune system 2, and Thursday is immune system 3. Okay, so Friday we will clean up or review anything that y'all are like, I really didn't get this. Okay, we are going to draw a big mind map for the immune system, so you'll have everything you need there. The immune system's pretty fun. It's not that tough. It's nothing like action potentials. But it is kind of like you learn about all these little pieces and then you got to figure out how they all come together. Okay? All right, so we will be done by Thursday of next week. Friday will be a review, and then your exam is Monday. So you'll have the weekend to study. I apologize, we're not going to be able to play a review game for this one, but you'll have everything you need, and it's a pretty short unit. I think it was like 8 days. Okay? All right. So today, your senses. What the heck is sensation? Action potentials, okay? Did you feel it or did you not? Okay? It's the actual happening. Okay? Did you feel it or was it so light that you didn't feel it? Okay? When you are diabetic, what do you lose? On the same vein as sensation. Yes, you're right. Insulin is a problem when you're diabetic, but have you ever noticed that diabetic people have to wear funny socks? No. None of you know diabetic people, I guess.
I do.
Old diabetic people will say that. Do you have a grandma or grandpa that's diabetic? You are? Okay. Well, usually it's older people. You don't have to wear funny socks, I bet. They wear these really tight socks. What that does is it helps with their circulation because their circulation's really bad. So they lose sensation in their feet. Feet are farthest from your heart. Okay? Lots of times they'll get up in the middle of the night and they might step on something and cut themselves, have no idea, go to bed, bleed all night long, and then they get up in the morning and they're like, what the heck happened? I got this huge flap of skin hanging off. Okay, so sensation is the ability to feel. All right, what is perception? Thinking about it, okay? What is your perception of this pain? Do you think I have some football players whose perception of pain is a little bit off?
Yes.
Okay, when you roll your ankle and you act like you're on fire, okay, that is not a very good perception of pain. Okay, I've rolled my ankle. It does not make me feel like I'm on fire, okay, or I've been shot. All right, I won't mention him, but he is a very large man. Had a problem with acting like he was on fire.
I know who it was.
Every time he was injured. And I hated for him to get hurt because I was like, God, not again. And what is it, a splinter? Like, but But eventually, like I would say this year, he has surprised me with how much better he has gotten. He had an issue this year that was constant. It was like every day. And so he would just say, I need you to fix this. And he would be calm. I mean, he'd be breathing like he was in labor. But, I mean, he wasn't rolling around, and he would actually let me touch it. There's been times when I've been evaluating him, and he grabs my hand and just, don't touch it. So, I mean, he's gotten a lot better. He's grown up a lot. Now, sensory reception, number 3, we know that all of this results from a stimuli. There's got to be some stimulus from the area. What is the chain of command? We've talked about this. What are the 3 steps for detecting a stimulus? What is the detection of a stimulus? Sensory, starts with an I. Things coming in. Sensory input, okay? Remember this? All right. Sensory input. Once we detect a stimulus, what do we have to do? This is hot. What does our brain have to decide? To move your hand. An appropriate response. What is that step called? Starts with an I again.
Interpretation.
Close. Integration. It is interpretation, but it's called integration. So we touch it, that's sensory input. Our body senses that it's hot. Our brain recognizes that it's hot, has to decide the response. And then what do?
Either move.
You move it, okay? You've got to act out the response. What do we call that step? If one was input, this would be
Output.
what type of output? Close. Motor output. We're not sensing it, we're causing an action, right? Our muscle has to contract in order for that to happen. Okay? Lots of times these are reflexes and they don't actually reach our brain, right? They go to what's called an interneuron. So, they're going to cause, these forms of energy are going to cause those shape changes within our receptor proteins. The sensory transduction process is there laid out for you. We've got the threshold potential. We've got summation at the where? Where does summation happen? It's not on the sheet. Axon hillock, very good. It's going to get amplified on its way to the central nervous system. What's our central nervous system? Brain and spinal cord, very good. The actual transmission of that signal while it's being amplified is called what? Saltatory conduction. What is saltatory conduction? The hopping, the leaping. Where are we hopping from? Node to node, okay? We're not going through what sections? We're skipping certain sections. Myelin sheath sections, the myelinated portions. Who is responsible for that myelin? Who makes that? Schwann cells. You see where all that beginning stuff comes back? If you didn't learn that first step of what are all the parts, you wouldn't be able to put it together now. Okay, so when you say, why do we have to know what parts of a neuron if all we're doing is learning what the neuron does? Because it's really hard to get both. And then integration, which is what again? And the interpretation or the deciding what's that response going to be is going to happen by the central nervous system. And we have a really cool process in our bodies called sensory adaptation. Come on. Clicker decided not to work today. Okay, there's our saltatory conduction. Schwann cells make that myelin sheath. We're hopping and hopping and hopping. Is that a better picture? I tried to draw that on the board the other day. Does that kind of explain it a little better? Okay. I'm up behind. We already knew that one. And we're getting there. All right. So we have this thing called sensory adaptation. Your senses will adapt. I put on some really nice perfume this morning. And when I was in the house, I was like, whew, this is strong. Do I smell it now? No. Why? My nose has adapted to it. My chemoreceptors, because everything we smell is a chemical, okay, my chemoreceptors have said, that's not important anymore. We've been smelling that for 30 minutes. Okay? Same thing when you walk in the boys' locker room. Right, Jordan? Braxton? When you walk in the boys' locker room for the first time during the day, what do you smell? Yeah. Nastiness. Dirty feet. Okay. Mold. Do you smell it about 30 minutes later? You're used to it by then. And most of the time throughout season, if you smell it every day, do you even notice it by the end of the season? No, but if I walk in there, I am blown away. Okay? And they clean it every day. It's shocking that it can smell that bad. So that sensory adaptation, they use the example of your clothes on your body that I've been using, but it goes across the board. Okay? If you're at a party and there's a strobe light, when you first get there, you're kind of squinting. Okay? Halfway through the party, are you still squinting? No, your eyes adapt. They adjust. They know the level of lighting that you're going to be getting. All right, now if you have, what is that called? Epilepsy, you may not adapt. But. All right, now there's different types of sensory receptors. Interoreceptors are those ones that are inside your body. If you have swelling that's pushing on a nerve or on an artery, you have little bitty cells in your body that are sensing that pressure. And that sense of that pressure is going to cause the pain signal to go to your brain.
Is that like when you get your infection of all down?
Yes, just like that. Those interoreceptors are the things that are sensing in your ear, in your semicircular canals, which we're going to talk about today. Yes, I think today. Yes, today. And they will sense when you're off balance. You've also got Xterra These are going to be things that sense external stimuli. So where do you think these are going to be found? Your skin and the mucus linings of your body that are reaching the outside air. So the first one is Mechanoreceptors. They're going to detect bending or stretching. Did you know that you actually hear with hair?
That's weird.
Yes.
You're going to learn it today. Okay, how much time do I have?
None.
Okay, we're good. You also have nociceptors. Noci is the Latin root for pain. Okay, so nociceptors are going to detect pain, which seems kind of funny because you're like, well, if I've got something that mashes my arm, am I detecting pressure or am I detecting pain? Well, that one would be pressure. This is in the instance of like when you slice your arm. Okay, if you cut it open, that's the pain that we're detecting. Thermoreceptors, what do you think you're sensing there? Heat or cold, the absence of heat. Chemoreceptors? Chemicals. And they gave you a couple different options there. Osmo, sounds like what word we've already studied. Osmosis, so that's going to be everything about water. Gustatory, that's kind of a funny one you probably didn't know about. That's your ability to taste. And then olfactory. Has anyone ever heard of your olfactory glands? It's in your nose. Okay? So your olfactory nerves, your olfactory glands, that all has to do with smell. The last one, did you know this? Electromagnetic. You have electromagnetic sensors in your body. Okay? It actually includes photons, which are light. It includes electrical signals. You can tell when you've been zapped. You know, when you scoot your feet across the floor. You can tell. And then magnetic. We're not very good at the magnetic part as humans, but there are some bugs and stuff that can sense the magnetic fields and things. Now, how do we hear? What the heck is this? Well, pull out your little eyeball or your little ear sheet. Okay, and you're going to look at it while I'm talking about it. This shows you all your little sensors in your skin. They just kind of line up under the basement membrane. Okay, now obviously your mechanoreceptors are going to be down here attached to your hair because hairs are going to have the easiest sensing of pressure and pain. This work? Yes, now it's working. All right, so to be able to hear, you hear by mechanoreceptors, that bending and that stretching. Now let's get to where we understand what is actually bending and stretching. Whew. Okay, this is where your Q-tip goes. Okay, Q-tip is here. You have this section here. What is this? Your eardrum. Has anyone ever bursted an eardrum? How did it happen? Soccer? Yeah. Okay, it happens pretty common. It's not super painful. Yeah. Lots of times if you burst an eardrum, you can plug your nose and blow like that. That normally would pop your ears, but if you have a busted eardrum, it'll blow air out your ears. Crazy, right? Someone can stand next to you and it goes, you can hear it blowing out their ear. It's really crazy. Any of you have Miss Lynch in 5th grade? She bursted both of hers at one point from basketball practice, getting elbowed by her girls. All right, so it's really called your tympanic membrane. If you think of the timpani, what is the timpani? Drums, right? Okay, so it makes sense that it would be called the tympanic membrane. Well, on the inside of this tympanic membrane, you have 3 bones. You've probably heard of them like the anvil and the hammer and stuff. That's not their real name. Malleus is the first one, incus, and then stapes. Okay, what root word are we, or what root language are we looking at here? Latin. Okay, it's always Latin. So those are the real names. And then the reason you need to know the anatomy is because it makes sense when you first start talking about how it works. You have these two windows down here. You have the oval window, right there, and you have the round window, okay? The round window is going to your cochlea. The oval window is going to your semicircular canals. Here's what happens. Sound waves, like this. They're going to vibrate your eardrum. If they're really loud or really deep, do you think the waves are going to be far apart or really close together?
Deep is far.
Far apart. Okay, they'll be far apart. If it's really high pitched like a dog whistle, what do you think it's going to be?
Close together.
Really close together. Okay, so if it like this, that means it's a really deep voice. If it's like that, it's probably really high pitched. Okay, so it's going to wiggle this membrane. What's attached to the other side of the membrane? Those little bones. The little bones are going to wiggle. Okay, they're attached to the oval window, which is just like another baby eardrum. And that baby eardrum, on the other side of it, has fluid that's kind of like jelly. Okay? So it's not perfectly fluid, but it's pretty fluidy. And there's infections and stuff that you can get in your ear that would cause it to kind of tighten up, and then you won't hear as well, you get an ear infection, all that stuff. So, inside here, we have fluid. And that's where we get down into, if you go all the way down to the cochlear duct. When you talk about the basilar membrane, the tectorial membrane, and all of that. And that is what your picture is about. All that it goes in and then in and then in. So it kind of keeps zooming in on your picture. So let's look at how we actually hear, now that we know how we get there. All right. So you have this fluid. Here's your oval window. This is a big nerve that comes in here. And as the fluid moves, it's going to move based on how that first wave was detected. If it was a big whoosh, like this, that fluid is going to come in real slow with these big pushes of fluid. If it was really fast, that fluid's going to go whoosh. Think of like ripples in a pond. Okay? So, what is it moving? Well, here's a picture that you're labeling, and then it zooms in like this. What it's going to do is it's going to, have you ever seen the gymnastics? When they run and then they bounce off that thing and then jump on the thing and flip around?
Yeah.
Okay, what is the bouncing thing? The springboard. Okay, thank you. Do you like that? That's on camera. All right, so the fluid is going to bounce off this springboard that you see here, this tectorial membrane. What that does is there's little bitty hair cells embedded that are attached to that membrane. Okay? So when it bounces, it's going to either pull or stretch or move those hairs. Those hairs are kind of embedded in this like jelly. Have you ever seen someone make a really fancy jello mold and they flip the pole over it and pull it off and it's like real pretty? Okay? That's kind of what we're talking about. It's a standalone jello. So when that fluid moves, it's going to wiggle those hairs. How hard or how drastic those hairs move, it determines what signal is sent to your brain. If it's really, really low pitched, like outside of human hearing, those hairs are moving, but it's not enough of a stimulus to cause an action potential. Does that make sense? You might reach close to threshold, but you might not reach close enough. Now if it's a dog whistle, some humans can pick up a dog whistle. Very, very slightly. Most of us can't hear a dog whistle. We hear the like shh of the air, but we can't hear the high-pitched whistle. That would be another one where we wouldn't pick it up. But when it's in the range of human hearing, that means it wiggled those hairs just enough to signal to these yellow nerves to send an action potential to your brain. Now, if it's a really fast wiggle, it's going to send a really fast action potential, and those fast spikes are going to tell you this is a high-pitched sound. Someone's screaming, okay, bloody murder. But if it's a really slow wiggle, it'll send really slow action potentials, and it might be the trombone players in the band hitting that really low note at the end of that one song. Okay? Question? Somebody had a question? No? Good. What is it? Lowrider? Okay, I couldn't remember what song it was, but I don't have this. All right, so we kind of understand how this works, how you hear with hair. Okay? Think jello, hair. Jello wiggles, hair moves. Kind of cool, right? All right, let's talk about balance. Down there at the bottom, you've got semicircular canals. Again, we're balancing with hair. It's kind of shocking, okay? These semicircular canals are going to go in 3 directions. Think of me having a pool noodle, okay? So one of them is going to go from the back of your ear to the front of your ear. So if I had a pool noodle right here, which direction is that sensing?
Front and back.
Front to back. So when your brain goes like this, that jello mold is sliding to the front. When your head goes back, that jello mold is tipping to the back. Okay, so it's not a vibration this time, it's literally the movement of your head. Okay, there's another one that goes out like this. What's that one going to sense? It's tough.
It's like
This. Okay? Because think about it, the jello mold is here in that tube. When I turn this way, it's going to shake that jello mold this way. When I turn my head this way, it's going to shake the jello mold back. The last one, kind of awkward, comes straight out the side of your head like this. What's it going to sense? Amber's doing it. This or this. Okay? So they have to have 3 to cover all the different directions of your brain. Okay, and I think I put, that's my old slide. My other slide had a better picture. So what's happening here? You've still got fluid and jelly, okay? But this time your jello mold is the only thing we're dealing with. We're not attached to that tectorial membrane. Almost time? Okay. So this jello mold, as you shift, is going to pull one way or the other. It's called a cupula, so make sure you know the name so when you talk about it, you can name it, okay, on the essays. All right, the hair cells are embedded in that jello mold, and if I shift my head this way, that top-heavy jello mold, that cupula, is going to slide this way, and those hairs will be pulled, and my body will be able to sense the direction I'm going in. Now, if you have an infection, and that fluid has tightened up due to inflammation and white blood cells and things being in there to try and fix the problem, are you going to be able to sense your movements as well? No, not at all. Okay, so that is why your balance gets so much affected when you have things like a ear infection or a sinus pressure problem because it's all connected.
So what makes you nauseous? Sit up?
That's more about blood flow in your cerebrospinal fluid. That's not so much your ears. Why do you lose balance when you have a concussion? That is all about your brain and its processing speed. Your brain has been damaged. Because when you go like this, it whacks the back of your brain against the back of your head. Not really this, yeah. All right, what did I not get to? Taste and that little last part. Okay. All right, the ampulla is just this little swelling section. I didn't hit that at the end of the canal, so that one's not hard to label. All right. Are we good? You go home and tell your parents you here with hair?
Yes.
Okay. Have a fabulous day.